When I started looking for jobs fresh out of university, I had this interview where a company asked me if I was familiar with CI/CD pipelines. I am in fact familiar with them, I said confidently. So they started asking me a bunch of questions about it, and I can't remember exactly what I said. I probably started saying something about a certain Italian plumber that likes to go into pipes. About 5 minutes in, one of the interviewers finally put me out of my misery and moved on with the rest of the interview. My ears were crimson by the time it was over. Needless to say, I did not get the job. In this channel though, we love to make every failure a learning experience. So I learned 2 lessons from this. If you don't know something, you should be honest and upfront about it, especially in an interview setting. Number 2, you should learn about CI/CD pipelines. Now I can almost hear you guys saying, "But little turtle, I want to be a software engineer. Why do I have to learn about pipelines? Isn't that the DevOps team's job?" If you want to be a software engineer and you say this to me, I'm gonna punch you in the liver. This is something you absolutely need to know about, especially if you want to become a senior dev at some point. And I'm gonna teach you about it. I'm gonna throw some problems you might encounter while working with a team to deploy some software. Then I'm gonna hit you with how a specific stage in a pipeline could help you solve that problem, along with some technologies I actually use at my current job. So next time you're reading a job description, you'll know exactly what they're talking about. So what's the point of a CI/CD pipeline? In your personal projects or in projects at university, have you ever felt anxiety and worried that the examiner or your lecturer wouldn't be able to run your project and as a result would give you a failing grade? It's kind of the same when you deploy something to production. You want to have some peace of mind. So what devs have done is to automate a bunch of checks before we actually deploy. And this is the beginning of the CI/CD pipelines. One such example is the pre-commit tool. This is a tool that runs some script or action before you commit your changes. At my current job, this is where my team have set up some code formatters and linters to ensure consistency. All of this happens locally on your machine. Now this is where we move away from your local development branch, because we store our code in GitLab. I like to think of it as a flavor of Git or GitHub. Now remember earlier when I said that we wanted to automate a bunch of checks? Well, the way you do that is through the use of YAML files. Here's an example of a YAML file with some jobs. You have the stages in the pipeline, something like build and test, and then you specify what you actually want to do in each job in that pipeline. For example, during the build stage, we might want to print out the fact that we're building the project. Now these scripts are not magically just running on GitLab. GitLab uses a built-in CI/CD system called GitLab Runners. For example, GitHub has GitHub Actions. It's kind of similar. An independent system you could use to manage your pipeline though would be something like Jenkins. Now if you see these in a job description, you'll know what they are and hopefully you'll be able to talk about them. The first stage in our pipeline is the pre-build stage. This is where we install the dependencies we need to be able to build the application, and we use tech like Gradle and PNPM. Then we have the formatting stage. This one's self-explanatory. We kind of just run the same checks we did on the pre-commit tool as a final safety measure. We use Google's formatting standards for our Java projects, and in order to manage that, we use a tool called Spotless. For TypeScript, we use ESLint. Next up is the build stage. This is where we actually run the scripts to build an image for the application. Just before the build though, we run the unit tests. This is probably the most interesting stage. Here's a question for you. Suppose we're building a web application that tracks how many games exist in the world. We call this app the product manager. We decide to start building this using the latest Java version at the time, which is Java 8. Some years down the line, we decide, hey, wouldn't it be cool if we could also track who owns each of these games as well? So we decide to build a separate project that depends on the product manager. We'll call it the customer manager. Here's the thing. At the time that we're building the customer manager, we now have Java 21 with a bunch of cool new features we want to use. Why don't we build the customer manager using that? So we end up doing it. Does that now mean that we'll have to have both Java 21 and Java 8 installed on the same machine? Won't that create a bunch of dependency issues with plugins and stuff? Of course it will. That's where Docker comes in to save the day. Docker lets us create isolated environments so that we don't run into issues like the one described above. That was a real issue that we faced at one point at another company I worked for. Now whenever you see Docker in a job description, you know what it does, and we'll have an example of where it can be used. Then we move on to the testing stage. Here's where we run integration tests, as well as other checks. We also use PyTest for mutation testing, and SonarQube for anomaly detection. Mutation testing is essentially a type of testing where some parts of the code are modified. Then the unit tests or integration tests are run against that modified code. For example, if you had the following if statement, PyTest would then change isTurtle to false, which should clearly produce a different result in the unit test. If the unit test still passes, then that could mean that there's something wrong with the unit test. Because then what is it really testing? SonarQube, on the other hand, just produces a bunch of statistics about your code, like how much of your code is covered by tests, how much technical debt exists in your code base, and a bunch of other really interesting things. Then we finally move on to the code review stage, where someone in your team will take a look at your code and suggest areas of improvement. This is my favorite part, because it's where you get to learn with and from your team. If you found any value in this video, please drop me a like and consider subscribing for more videos like this. Consider joining my brand new Discord, even if it's just to say hello.